Here is an animation of our full system design modeled in SOLIDWORKS.
Okay, here's a look at our system. It is powered up. We've got our two power supplies here, one which goes to the solenoid control board and the other which goes to the laser controller and the reference laser. We have our main switching board here, which this switch operates the lasers and this switch here operates the solenoid control. All of our motors are powered up and ready to go. We have a power strip back here. This 12-volt wall power supply connects to our solenoid control board to give 12 volts DC to our solenoid. And then our 24-volt onboard power supply is connected to the wall city power through this plug. And here's our power supply. We can see that it's powered up by this green LED. And then these red and black copper wires route all the way through our cable trays up to each motor. So we've got power to this motor, power to this motor, and power to this motor. Okay, here we have the solenoid and the venturi pump, and then this board here is the solenoid control board. The solenoid control board is connected over here to our main switching board, and on this board we have a switch to control the solenoid and allow air to flow through it, and we have another switch that turns on the lasers. Come back over here, this hose right here is connected to an air compressor, and when the solenoid is flicked on, air is allowed to flow through the solenoid into the venturi pump, and the venturi pump creates vacuum pressure for our lens housing unit. Okay, here we have our lens housing unit. You'll see that we epoxied a glass slide on top of it so that the laser diode light can actually get up through the housing unit, and it's airtight so that the vacuum pressure remains when we connect or attach a lens to it. We have actually two different sizes of lenses that can be used for the unit. This little tiny guy here and this big one here. And you'll see that there's no pressure until we actually flick the unit on. Okay, here we have our laser housing unit and our camera housing unit. This unit is taped down to the table so that it's aligned with the parabolic mirror we have up here. Right here we have the reference laser, which was purchased from DigiKey, and then we have the test laser diode over here. In this tube is the laser driver board, and these two screws are used for positioning and to hold these two lasers firm during alignment. On the camera we have a filter so that the light from the lasers doesn't saturate the camera, and here's our switch which turns the lasers on. So you'll see now that they're actually on, and then if we shut this, they turn off. Now we're going to show the alignment process.
This is our graphical user interface, which was programmed in C# using Visual Studio. The GUI has 4 picture boxes and a bunch of buttons which allow the user to take a picture, grayscale it, and if needed, create a binary image from the grayscale image using a threshold slider, which is not pictured in this slide. The data obtained in the text box on the right is, in this order from left to right, the pixels X value, Y value, and intensity value. Code was written to extract the data and write it to a text file so that it could be used to create the following plots in MATLAB. Here we can see 2D images generated using our data in MATLAB, which represent the bitmaps which we extracted the data from. Here are the 3D plots of the data which show how intensity increases toward the center of the beam. In the future, We would like to implement the fitting algorithm in C# so that the use of MATLAB is not necessary for operation.